Okay. So we're going to talk about, so far we've done some arithmetic and some control flow, but we haven't worked with any kind of collections of data. And that's kind of the whole point of trying to do this on a computing platform. If we were just doing things one at a time, we could probably do it in Excel or even by hand, right? But the idea is to do this at scale, to simulate hundreds or thousands of cells, or maybe hundreds of molecules, and see how they act in a system and what properties emerge. So the way we can do that is through collections of objects. So the most common types of these are ordered one-dimensional collections of objects, such as strings, lists, and tuples. So these have a defined syntax. So strings, we've already talked about being identified by quotation marks at the beginning and end. Lists have these square brackets at the beginning of end, and then tuples have these curved brackets at the beginning of the end. And you can use the same set of operations on each of those. They have very similar functionalities, but there are some subtle differences. So let's kind of go into that a little bit. So we've talked about this a little bit. And I don't want to focus as heavily on strings because they're not necessarily as useful as the lists and other collections that we want to work with, but they are a very intuitive example. So you can think of a string as a sequence of case-sensitive characters. So these can be used as the names for different objects in your simulation, or they can be used as data in themselves. In bioinformatics, classically, all of the base pair data from DNA and RNA or proteins is used, and in that case, strings are very useful. But you can compare strings with conditionals, with greater than or less than and equality and inequality, and you can use len as a function to retrieve the length of a string in the parentheses. So let's start doing that. Okay, so I'm going to go ahead and I'm going to, let's practice first, save. So let's save this. So we've saved it, and then let's download this as an IPYNB file so that it's available to us offline. And then we'll post that IPYNB file in Slack, or you can email Hayden to request it if you want to see those solutions at the end. But now that we've done that, let's go ahead and launch a new notebook, a new clean notebook. Python 3, and let's practice renaming this module 2. And it's unsaved, and then we'll save it in a little bit. But yeah. Oops. Okay. So we can have an example string, s equals a, b, c, and then we can do len s. Now, if I hadn't told you what len s is, there's a couple ways to know that it's a function. One, you have these parentheses. Whenever you see those parentheses, you know some kind of action is happening. Whenever you see those parentheses attached to some kind of phrase, that's when you know it's a function or some kind of action is occurring, because what you do that action on whatever's inside the parentheses. So in this case, we have a string called s with the value ABC, and then len is going to be acted upon ABC. So let's run it, and it prints out 3. So you might be able to figure out that len means length. So len is always going to print out the length of whatever is inside there. we've already worked with a different built-in function in Python, print, right? In Jupyter Notebooks, in NanoHub, functions are always going to be in green. These built-in functions are always going to be in green, and that's another clue about what's happening there. So if we print s, ABC, so it's going to do that same thing again and again. But we can also access elements of a collection, whether it's a string or a list, based on the order of it. And that's called slicing. So let's make a longer string, A, B, C, D, E, F, G. Let's execute that. Length of S is now 7. So if we want just some of the characters of that list, we can slice. So slicing works through indicating with brackets where you want to start, where you want to stop, and where you want to step. Step is the default. Step 1 is a default. So you can just indicate the start and stop. So if we do S 2 to 5, it prints out CDE. Okay. So remember, and you may have noticed in Python, you always start with 0. So A is the 0 ordered index. B is, so index refers to the position. A is the 0 index of string S. B is the 1 index of string S. And C is the number 2 index of string S. So 2, 3, 4, and then 5. The last number tends to be exclusive in Python. So 2 to 5 means 2, 3, and 4, which is C, D, E, which is what got printed out there. Let's make this longer. H, I, J, K, L, M, N. Okay. So now if I wanted to do 2 through 8, it's going to print out 2, 3, 4, 5, 6, and 7. So it's going to print out 6 characters. C, D, E, F, G, H. If I wanted to increment based off of 2, it's going to print every other character between 2 and 8. C, E, G. So C, skip D, print E, skip F, print G. Oftentimes, if you have a really long list, or so again, all of these that I'm showing you on string because it's super intuitive can be done on list as well, and that's where you're more likely to do it. If you have a long list containing all of your cells, you may not know how many there are in there at a given time. In that case, you can just go 2 to the end, and it'll print out. It'll access to the end. If you don't specify accesses to the end, and then if you don't specify the other way, on the other side, it accesses from the beginning. And then the other thing you can do is len of S. So you can specify it like that. So if I print from the beginning to length of S, it's going to print out the whole thing. Finally, the last thing that the last thing to know is that you can also count backwards from the end. So if I do -1, that's n, because it's from the end, it's -1, and then -2 is going to be m. So if I do that, if I do -1, n is the last, is where it ends, and remember it's exclusive, so it goes there so it ends with, so it only prints that part out. And if I change this to -3, right? -1, -2, -3, and it's exclusive, so it's going to end at K. And then finally, we should also mention that you can count backwards. So we can do 9 to 3. increment by -1. So it goes G, so 0, 1, 2, 3. And the third one doesn't get counted. So it really it really ends there, and it goes J, I, H, G, F, E, right? And then similarly, you can do this by -2s if you wanted to skip to every other. J, H, F. So these are just examples for slicing. And again, you can do all of these same things on lists, and that's where you're more likely to use them. Similarly, you can access individual members, and this does get into what we're trying to do. You can access or what you might need to do in a loop situation. You can access individual members of the list. So S7 is going to give you the 7th index item or the 6th. Sorry, or the 8th item in the list. So actually, let's do something simpler. If I do 3, right? 3 is going to give you the 4th letter of the alphabet, 4th letter in the list, because it's 0 index, 1 index, 1 index, 2 index, 3 index. So D is what it's going to give you. And you can also count from the back. -1, -2. And then if you try to do something that's not in there, right? We don't have 22 letter, oops. You get an index error. String index out of range. So this has a range of however many letters this is. What was it, 12 or something like that, or 14, right? So if you do a number outside of that 14, you're going to get index out of range. Any questions about this? Okay, I don't see any questions. Oops. Let's take a look at this first problem there. Given a string S of length of about 200 characters and 4 integers, A, B, C, and D, return the slice of the string from indexes A through B and C through D inclusively. Okay. So let's, oops, okay. So S2, I'm going to call S2 equals all right. So if I do len S2, I can see that there's 47. So if I want to return so let's look at what is S2 22. It's H, presumably it's this H, and then S2 27, presumably it's that Y. So if I want to return 22 to 27, it's not going to be inclusive, right? It's going to be exclusive of this 27. So it's going to be humped. So if I wanted to do it inclusively, I just do 28. So I just have to increase it. So if I do A equals 22, and then you can also do a colon to put multiple commands on the same line, sorry, semicolon. B equals 27, C equals 0, 1, 2, 3, 4, 5, 6. Let's say C equals 6. And oops. If I do a comma there, it's going to have a issue. But if I do a semicolon, it basically treats it as a new line. D equals 11. Okay. Then I can say S2 from A to B plus 1. I'm going to put a space in there, empty. And then remember, we can concatenate strings. So that's what I'm doing with those spaces, with those pluses. C to D plus 1. So it said dumpty, whereas if I don't include the plus 1, I get humped dumped. So it's just a reminder that the point of that is to remind you that the last number is exclusive, and you need to factor that in when you do your slicing. Okay. Any questions about that? So before we talked about range, right? So if I do range 5, if I do print Z for Z in range 5. So that's my conditional. And if I my body, I say print Z, it's going to print 0, 1, 2, 3, and 4, right? I can also put those into a collection called a list. So if I could do list range 5, it creates a list starting at 0, starting at 0, ending at 4, and the 5 is exclusive, right? So it doesn't include that 5. It includes 5 numbers from 0 to 4. But if I do list range 5, I don't get to use it. So I have to name it something. Let's name it nums equals list range 5. Now that I've named it nums, I can access things in there. So I can do print nums 2 to 4. And these need to be brackets. So it prints 2 and 3 because the 4 is exclusive, or I can loop through this. For X in nums, print X, right? Because nums is that list. So it's going to print each item in that list, 0, 1, 2, 3, 4. And just like before, I can do indexing from the back. Nums minus from the beginning, 0, 1, and then it's not including the last, the -1 and the -2. So it drops to 3 and 4. And just like before, I can do nums. If I don't specify the beginning and end, it includes all of them. And I can specify individual ones in them. Num2 is 2, nums3 is 3. And that just happens to be because of where they're located on the index. So one thing, let's take a look at this one right here. Nums 2 to 4 equals 8, 9. Okay. So first, let's remind ourselves what nums 2 and 4 are. They're 2 and 3, right? But if I say nums 2 to 4 double equals 8, 9, I'm going to get false, right? Because that's testing the equality. It's false. Now, if I change that to a single equals, and then I print nums 0, 1, 8, 9, 4. So the single equality, that's one thing to be very careful of, is going to reassign those numbers. Lists have a property called mutability, meaning you can reassign numbers in a list. Now, if I go back to my string, right? Let's remember what S2 was from 2 to 4. So if I check what S2 said MP between 2 and 4. If I do S2 set of 8, 9, let's say it's YX. We get an error. String object does not support item assignment. So you can't edit a string in place like that, which kind of makes sense. You don't want to randomly change the name of parts or change parts of a name of something, right? Because string is all part of a whole. But in a list, each one of these is treated independently, and you can update it on the fly with that assignment that we've shown you there. So that's something to keep in mind. Lists can be updated. Strings have to be, the whole string has to be changed. Now, if I said S2 equals Z, X, Y, W, U, Q, R, if I did that, that would be totally fine because I'm just changing what the string stands for. But if I try to update part of it, it's not going to work. Whereas with a list, I can do either. I can reassign the whole list or I can update part of it. Any questions about that? So that's what this was saying. Strings are immutable. They can't be modified in place in that way. You can't say if string S is hello, you can't say the zero indexed character in string S needs to be a Y. You can't do that. But you can say S is equal to Y plus the rest of the old S. You can do that. You can change the whole string. You just can't change a constituent part of it. But lists you can. So let's talk about for loops again. For loops have a loop variable. So that's we've been using as X and Z and stuff like that. So here's the loop variable X. And it iterates over a set of values. So we showed how it iterates over nums, right? And it does some expression for each item in nums. It can iterate over any set of values, not just numbers, right? So I mean, I haven't shown you that yet, but imagine you have a list of cells in your simulation. Cell 1, cell 2, cell 3, and cell 4. You can do for X in list of cells. Now, once you run functions, you can actually have each cell in there do it. But right now, those cells are just strings. So you can say, let's just say print X right now. So it can print cell 1, 2, 3, 4. Once you learn how to do more stuff, and once these are more than just strings, once they're actually objects in Python that have data, then you can actually do interesting stuff. But you can imagine how you can iterate over cells and have each of them do stuff now. But in order to prepare for that, let's make sure we master how loops work. So let's break out S2 again. Let's say S equals A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. Okay. Now for index in range len S. If S index equals I or S index is equal to, let's say O. Oops. Print there is an I or O. So let's talk about what this is going to do. It has this string S, and then for each item, it just happens to be called index, and indexes, and it happens to check that string at that index, but this could be for anything. This could be for T. Right? This is just a loop variable to keep track of which part of the collection we're working with now. So we haven't done this construction before. What is range len S doing? Let's just check. So len S, we know. Len S is 15. Range 15 is, it's going to have all the numbers from 0 through 14, right? For range 15. So this is a nested function now. Range is one function, len is another function. And so it interprets the innermost first. So length of S is going to be 15, and then range 15 is going to be numbered 0 through 14. So for T in numbers 0 through 14, if the T item in S, so if the 0 item in S, if the 1 item in S, if the 2 item in S is equal to 1, or if that item is equal to O, print there is an I or O. So it printed twice, right? Because it went through, and then when it hit there, it met the condition and printed that, and then it met the condition and printed O. So we can change this to illustrate what's going on. Let's do this. And then let's do an else. Let's change that to there. Okay. So now it's going to print for every index, for every T in that collection, it's going to print the letter in the string. It's going to print whether it is an I or an O, if it meets that, or else it's just going to print the letter of the string. So it goes A, B, C, D, E, F, G, H, I is an I or O. J, K, L, M, N, O is an I or O. Any questions about that? Okay. So there's no questions, meaning I think you guys are getting the hang of these loops. And now we're going to change it up a little. So far so here we've done for t in this collection, and this collection happens to be numbers, right? For t in 0, 1, 2, 3, 4, and then we've used t as a number, as an index variable to slice different parts of S and do this test. Alternatively, you can do this whole thing. You can do this whole thing like this. So instead of for t in range S, we can just say for t in S. And then if t is I, or if t is 0. So now t is going to embody part of S each time. So we'll print t, and then we'll print t. So it's the same thing, except for instead of using t to slice, instead of using t as a number to slice in S, t is just going to embody one of the characters in S. So that may be made more clear by using a descriptive variable here. Oops. Right, you get the same output, but for each character in S. And again, one thing I want to emphasize, you don't have to memorize all this. All of this is available in a little cheat sheet. You just have to be able to recognize it with the A to that cheat sheet in the little drop-down menus that you're going to choose from. So don't feel overwhelmed if there's too many things to keep track of. You just want to be able to, the goal of today is to be able to follow the logic of everything that you're seeing, so that you can understand it when it's being used in a simulation context. Okay. And James has just posted the link to the cheat sheet in the chat. Okay, so let's do an example. So this is a little bit of a complicated example. We've got two strings, and letters equals some random lower and uppercase letters, and then we've got word equals W exclamation point O parenthesis or percentage R question mark D. And then we're going to do two versions of navigating this. I equals 0. While I is less than len of word, so word is going to be 1, 2, 3, 4, 5, 6, 7. So it was basically while I is less than 7. Car equals word I. And then if car in n letters, print car plus is a letter. Oops. Else print car plus isn't a letter. And then because it's a while loop, we have to initiate the loop variable outside, and we have to increment it ourselves. I plus equals 1, meaning I equals I plus 1. So if we run this whole thing, So it's still going, right? When you see that plus sign, it means it's still going. Okay. So it's taking a really long time, right? With the asterisk. So let's investigate what the issue might be. So let's hit that stop button to interrupt. And whenever I have something I'm not sure what's going on, what I do is I use a print statement to clue me in on where this thing might be getting delayed. So now I'm going to print I. Okay. So there wasn't an issue. It looks like it was just the network was a little slow. So I'm going to run it again without the print I. Shift enter. Yeah, it was fine. So okay. So it says W isn't a letter because W isn't part of this. Exclamation point isn't a letter. O is a letter because O is right there. Percent isn't a letter. R is a letter because R is right there. And then it says D isn't a letter. Okay. So that's one way. And now we can convert it. We go back. We can convert it using for car in Word. It would be a lot cleaner code. So it's the whole thing down there. Instead of a while loop, for car in, instead of length of word, we just say for car in Word. We don't need this line anymore. We don't need this anymore. And we don't need this anymore. So it's a lot smaller, right? Okay. Any questions about that? So this is the same thing. I think I'm going to skip this one because it's almost literally the same same thing. I want to get into these loops. Okay, so let's take a look at this one. Animals equal, and then it's a loop, it's a list, right? Square brackets means a list. And then inside the list, each item in the list is a string: cat, dog, monkey. So for animal in animals, print animal. So remember, print always, any function always has those curved parentheses, whereas all lists have these hard square brackets. And it prints each one of these on their own thing. Just to be clear, animal here can be anything. We could call it D23 and it would still work the exact same. It just happens, it is a nice thing to use descriptive variables here, right? We have a descriptive variable for this list, and you can use a singular of that as a different descriptive variable, but it's not related to, it doesn't have to be related in any way. It's just any variable. Okay. So now let's work with what we know about lists, what we know about conditionalities or conditionals. And I've got 1242. Let's spend 3 minutes coming up with some code that will address this issue. It returns a list containing only the elements that are common between the lists. We haven't talked about how to create a list, so just have it print out the elements that are common. Yeah, so I have 1243. Let's go to 1246 on that. Okay, I've launched the poll to see where we're at. Okay, so I'm going to go ahead and get started with a very simple approach for Z in A for W in B. So this is a set of nested for loops, meaning a for loop inside a for loop. If W equals A, so I forgot the quote, the semicolon there, so it didn't indent to the right place, right? So I gotta print Okay, so this is wrong, right? It's got to be if W equals Z. Print W. And then because it's a for loop, I don't have to increment. I don't have to do anything else. Now let's have a print statement to show when I'm done. Okay, so now that gets most of them, right? But it has duplicates. So how can we avoid the duplicates? Well, if you remember our conditionals from before, there's also the option for, so we've been using one here. If W in, so we can do for Z in A, if Z in B, print Z. So again, so that's easier, right? It still gets them all, but it still has that duplicate, right? So how can we address that? Well, part of this goes to the order of, goes to the issue of adding things to a list. We haven't talked about how to do that. So we'll create a list called C. We'll create an empty list. And then we add things to a list through append. So we're going to append Z to the list C. And then after the end of this, we're just going to print C. So it still has the duplicates, but now it's in a list. So we've addressed that. And then now we can add a third conditional. If Z not in C. Right? So for Z in A, for each one of these, if it's in B, and then if it's not in C. And now we don't have the duplicates, and now we also know how to add things to a list. And again, this is a kind of a dumb CS exercise, but you could imagine having a list of cells that have a certain receptor portfolio and a list of cells that are actively dividing, and then you want to do stuff. You want to create a set at the union of those cells and only have those cells undergo some third process. And that's kind of how CompuCell works. It keeps track of all of these things for you, and then it executes these things based on different physical conditions and parameters, and then you can start to see emergent processes. That's what's really cool about it. Hopefully that's motivating. So we've done lists and we've done strings. One thing that I should emphasize is that lists can have multiple items. So let's call it test list equals equals epithelial equals X. Remember that variable X from before? And or actually, let's do this. This will be funny. Let's do C, the list from above, and let's do the number 3. And then let's print test list. Right? So now this list has a string in it, it has a list inside of it, and it also has a number and an integer. So lists can have discordant objects, but objects of different types, but we can always test list. Let's update that for that second item. And remember, second item is first index. Let's just update that as as mesenchymal. And let's print test list now. Right? It can be updated. This is what's called mutable. It can be updated. Remember, strings can't be updated. Lists can be updated. There's something that's just like lists, but they can't be updated. And that's called a tuple. And a tuple is represented with parentheses as opposed to the hard brackets. So everything else about it is the same. So if we did test tuple equals epithelial, a list 1 and 3, and then a float 3.15, print test tuple. And then if we wanted to try to edit, let's get rid of that list. We wanted to edit that second item in the test tuple as we're going to get an error, type error, tuple object does not support item assignment. You can't replace it that way. Now you could create a new tuple, and you could also call that new tuple test tuple and have it, be whatever you want, but you can't edit it in place. And that can be kind of useful so you don't accidentally overwrite stuff. So sometimes you might want to use a tuple if you don't want it to be modified. Tuples can be sliced the same way. You can iterate over tuples and lists in the exact same way as you did from before. Yeah, so this I don't know if this is well, we can just do it. Okay, so we need a tuple equals, and it needs to be something with integers and strings. Okay, I'm going to shorten this and type that all out. And just like lists, tuples can contain multiple types of objects. Okay. And then I'm just going to copy the rest of this code in. Nums equals words equals. So these are empty tuples. for T in a tuple, nums equals nums plus T, and I'll go over what this is doing in a second. Okay. So we had a tuple that contained tuples, 1 epi, 2 mes, 3 epi, 4 mes. Maybe this was the cell number, and then this was what type of cell it was, or something like that. And then you have an empty tuple for nums and an empty tuple for words. So for T in a tuple, so T is not going to be this, it's not going to be this, it's going to be the whole individual element. So T is the tuple 1 epi, or T will become the tuple 2 mes. So for T in a tuple, nums equals nums plus T0, meaning the first indexed item in the tuple. So nums plus 1. And if T is not in words, then it's going to be words equals words plus the 1 indexed item there. Meaning if T1, if the word from the tuple isn't in words, then we're going to add it. We're going to add that word to the tuple words. And then we're going to take the minimum number in nums and the maximum number in nums, right? So the smallest number in nums and the biggest number in nums, and then we're going to count the number of unique words. So let's print nums, print words. Okay, so the numbers are 1, 2, 3, and 4, which are these. So that's collected all the numbers. The words collected all the words, epi and mes, and then it printed the minimum numbers, the maximum numbers, and then the number of words in this new tuple, the number of unique words. So it may not be immediately obvious how that can be used. The nice thing about using tuples instead of lists is you can't overwrite stuff. And so that can be useful. So oftentimes functions, we'll do functions in the next lesson, but oftentimes you collect the variables from functions in tuples so they don't get accidentally overwritten. Any questions at this point? So we've covered a lot of this. So lists are ordered sequences of information. They can be accessed by their index, and they have square brackets, and they contain elements, and they can contain mixed types. And it actually is fairly common. List elements can be changed so list is mutable. It's not that common in Python, in CompuCell3D context, actually. But list elements can be changed so list is mutable. That's the big difference between them and tuples. They can be indexed in the exact same way as before. So these are the exact same way we've done with slicing of strings. So we're not going to repeat these, but they're available to you in the PowerPoint slides. They are mutable. So we can edit. I showed you how they could be edited in a way that strings cannot, right? So if you have a list 213 and you change the second item of that list or the one index item of that list to 5, that 1 becomes a 5, and now L is 253, but it's the same object. Whereas with the tuple, it'll throw you that type error. Tuples can't be updated. And then just like tuples and strings, lists can be iterated over a list. You can add elements to a list, as we mentioned, with append, and append comes in after a dot. So every object in Python, everything in Python is an object, and objects have both data. They have both data in a certain format, which we've talked a lot about, and then they have some functionality or methods associated with them. For lists, one of the methods is append. So, and you always identify methods through dot notation. So dot append, and then oftentimes they'll have parentheses for an input argument, just like a function. So this is basically like print, except for it's saying add it to a list, add it to that list, and you're adding 5. So you can do that here. List 1 equals 2, 3, 6. List 1 dot append 23, and then print list 1 2, 3, 6, 23. You can access this through that method. So the object name and then the method in dot notation and parentheses. Sometimes they have an input, sometimes they don't. We can also do list 1 dot. So okay, let's do list 1 dot append -5. So now list 1 is 2, 3, 6, 23, -5, and I can do list 1 dot sort. And now I'll print list 1. Right? It sorted them. Now, because lists are mutable, when I did list 1 dot sort, the list itself got changed. Other stuff that's not mutable, that can't be changed, you need to capture that output in a variable. So I can do list 2 equals list 1 dot sort, and then I could have that output, that sorted output. But again, you don't need to do that for a list because lists are sortable, but for other things, you will need to do that. Yeah, you can concatenate lists just like you concatenated strings. So we have, what are the other lists we've had? We have list 1 and we have test list. So print list 1, print test list. There's no capital list 1 in my file. I need actually this. So that was list 1, epithelial, mesenchymal 3. Test list was -5, 2, 3, 6, 23. And then I can concatenate these, right? List 1 plus test list. We'll call that list 2. And then we'll print list 2. Right? So I just added the items in there together. Right? But if I do this is, you know, somewhat important. List 1 dot append test list, it's going to be different. Now if I print list 1, right? Because it just added that whole list as the next item in list 1. Whereas up here, when I did the concatenate with the plus, you get a list too. So there's a question, how does sorting work with non-numerical data? Well, let's take a look at test list sort. So it's not supported between instances of integer and string, but if we had then we did test list 2.sort. And then we did print test list 2. It would have alphabetized them. So it can't do it between strings and numbers, but within that category, it will just alphabetize it. There are ways to remove things from a list. So you can delete things from a list through a specific index. So if I want to remove cat from this list, test list 2, I can del test list 2. So this is a function, right? Because it has it's green and it has the parentheses, test list 2. And I just get that index 1 item to get rid of cat because it's right there. And then if I print test list 2, I removed cat. Now it's a donkey zebra, right? The other thing you can do, and this is actually really useful, is you can use pop. Pop returns the removed from the list. So test list 2.pop, and it returns zebra. So if you have a bunch of cells in a list, you can pop the last one out of there, do something with it, and then pop the next one out of there and do something with that. And that way you'll never accidentally repeat. And it updates that list from above. So it takes it out of that list in case some other process wants to come along. And then you can do remove works similarly to del. It removes that specific element. If element occurs multiple times, it removes the first occurrence of it. So if we do L equals 1, 2, 5, 44, 1, 42, if I do L dot remove 1, and then I print L, so remove the first one, and then if I do L dot remove 1, and then I print L again, it removed it both times. And if I try it again, so if I run the same cell again, I'm going to get an error because there's no more ones in there to remove. Okay. You can convert lists to strings and back using command list or the command str. So let's look at what S2 is right now. S2 is that, right? So we can do L2 equals list S2, and we can print L2, right? So it moved every character into its own item of a list, right? It converted this string into this list. Okay. Well, let's go back to that. Okay. So you have a tuple. The tuple consists of 4 tuples. And it's 1 epi, 2 mes, 3 epi, 4 mes. That's what a tuple is. It has an empty tuple nums for keeping track of the numbers, and empty tuple words for keeping track of the words. And then for T in a tuple, it's going to embody each one of these elements, right? So it's going to embody 1 epi or 2 mes or 3 epi or 4 mes. And it's going to add to nums. It's going to add the number element of it. So for each T in a tuple, it's going to add the number part of it because that's the 0th index. So the 0 index one of these is 1. The 0 index of this is 2. The 0 index of this is 3. So it's going to add the numerical part of it to nums. And then it's going to check the word part of it. The 1 index, the 1 index, the 1 index. It's going to check the word part of it and see if it's already in words. If it's not in words, it's going to add it to words. And then min underscore n is the minimum numbers, and max underscore n is the maximum of numbers. So it's going to take the smallest number that's in nums and the biggest number that's in nums. And then here we're going to find how many unique words there are in words. So, and then we create a new tuple that contains this data, and then we print that there. So we're going to print the minimum number, the maximum number, and the number of unique words. And then here I just print nums to show you what nums is, and I print words to show you what words is. And that's what comes out. 1, 2, 3, 4 is all the nums from that list. Epi and mes, remember, it said if it's not already in there, so it doesn't duplicate. It says epi and mes, and then it prints out the beginning, the ending, and the number of unique words.
Hey, Bobby.
Yeah.
I think since it looks like you've still got a little bit to go, we'll extend this session till 1:30.
Okay.
The extra session today isn't going to be super long, so that way we can keep things on schedule and get people onto their lunch at 2. But just to let you know, we want to stop at around 1:30 here.
Okay. Yeah, and some of this is not that needed, so maybe I'll skip some of this. Yeah, you can convert a list to strings, but this is something like, yeah, you're not going to need to do. You can split a string based on characters. You can join a list of characters into a string, but again, these are more CS stuff. I don't know that you need any of this in the context of CompuCell. So let's go ahead and do that. I think we just need to know more about how these things function, and so let's work on the bigger stuff instead of those little operations. Yeah, we did sort. You can also reverse to undo sort. I mean, there's all kinds of this stuff, but again, that gets more into data science stuff. In CompuCell context, you don't have to do a lot of this. Lists again are mutable. That is important. You have to understand that lists change, strings and tuple do not get edited in place. You can reassign them at any point, but you don't have them edited in place. Okay, this is going to underscore that issue. So let's go ahead and do this. A equals 1, B equals A, print A, print B. Okay. What do you guys think is going to print? It should be 1 for both of them, right? Now, if I go ahead and change B equals 23, and now I print A and print B, what's going to print? A should still be 1, and B should now be 23. So that's all completely intuitive. For lists, this gets kind of funny sometimes. Okay, so if I print hot right now, what do I expect to see? I expect to get a list that includes red, yellow, orange, and pink, right? Because hot is equal to warm, and we've added pink to hot. Right? That's completely expected. Now, what happens if I print warm? Warm also got updated, and that's because lists are immutable. So if you have two things pointing at the same list, two variables pointing at the same list, you change one, you're going to change the other. Simple variables are not like that, so you don't have that issue. Sorry, I said that completely backwards. Lists are mutable. So if you change a list based off of one thing, based off of one variable, it's going to change the list based off the other variable. Whereas numbers are not mutable. So if you change one number, it's not going to change the other one. Okay. So lists have this property called side effects where this happens, because hot and warm are aliases. They're two lists that point to the same underlying thing, right? Both hot and warm are pointing to the same place in the memory, whereas A and B have independent identities from the beginning. The way around this is, instead of saying chill equals cool, you can clone the list. You can copy it basically. So it equals to cool. You can say chill equals cool from the beginning to the end. And now you have two different lists. So you can append one of them and not interrupt the other. Sort similarly is going to mutate stuff by changing it in place. It doesn't return anything. So I demonstrated that before. So it's going to change the list in place. So if you don't want to deal with that, you're going to want to capture that. So let's do that.
Do we expect the same for strings too?
Strings are going to act immutably.
So if we add at the end
not act
something
like
to one of it, it should not change the other one, right?
Correct. Okay, so here we've got so, and again, so a lot of this stuff doesn't come in to play that often. You don't need to know this, but if you get an error that you're not expecting, get a result that you're not expecting, this could be an issue, and it could be something to play with, to fix. So I wouldn't worry about memorizing all of these rules. Okay, well, let's take a look at this. Warm equals red, yellow, orange. Sorted warm equals warm dot sort. Print warm, print sorted warm. right? Sorted warm is none because warm sort just changes it into place. Print warm, print sorted warm. So okay, we've talked about how lists can be nested. You can have lists inside of lists, and this can, this is also another source of side effects. But there are these are not things that you need to worry about managing by yourself. CompuCell3D is going to handle a lot of this kind of stuff for you. The one part of that is avoid mutating a list as you're iterating over it. And this is important. You don't need to type this out, but for E in list one, if E in list two, remove E from list one. Don't do that because that's going to change list one. You can do it, but it may act in ways that you don't expect. The way to do it in a more appropriate way is to create a copy. And then for E in list one, copy. If E in list two, remove it from list one. That way you're not affecting what you're iterating over. Okay. So yeah, so we can do this exercise now. And then I will also throw up the poll. And you can proceed directly to your break. This is the last kind of slide. So, and I'll show the solution too. Okay, so the module experience questionnaire is up. And you guys can work on this exercise. I will show a solution for it in about 5 minutes. But other than that, we are going to, what time are we reconvening?
Well,
So Hayden is going to do a brief discussion orientation session immediately after this. And then
Okay.
we're going to have a break.
Okay. So yeah, at 1:30, Hayden's going to have a discussion here, and then there'll be a break, I guess, at 2 for lunch.
yes.
Please do fill out the module questionnaire. That's really helpful to us to have everyone fill it out.
We have a question in the chat, Bobby, from AJ about why did warm sort output none in the previous example?
Okay. Well, that will be clear, I think, after I show this solution.
Okay.
Okay. So I'm going to show the solution now. Oh, here. Okay. So I've got a list, test list 1. I've got some numbers in there. And I'm going to do test list 1 dot. I need to create a sorted list and a reverse list. So I'm going to do test list 1 dot sort, and then I'm going to copy this guy over as sorted list. Then I'm going to do test list 1 dot reverse, and then I'm going to copy it over. And then now I printed out my sorted list 1 through 8, and my reverse list 8 through 1. Now, if you had done this instead, if I had done this, I would have printed out none, because this doesn't return anything. So some things that we've seen have returned something gets printed out. So if I do, right, nothing showed up. It didn't return anything. It just changed that list inside. Now if I do this, test list 1 dot sort, now if I, okay, so test list 1 dot sort, now the list is sorted. So now if I set it equal there, now we're going to have a different problem. Now sorted list changed because it's going to forever be tied to test list 1. So when test list 1 got reversed here, it took on the reversed identity. So that's why we had to do the copy. We had to make a copy of it when it's in the condition we want. And then similarly make a copy of it when it's in the condition we want. Does that make sense, Ajay? Okay. Well, that is it for this module. Next, we're going to, well, if I copy the input list, we're going to get the same issue. So I'm gonna do this here. Okay. Now, instead, I'm going to do copy list equals test list 1 sort, right? Now I'm going to change it, do this. Sorry. Let's, okay. So I've got copy list. Now, if I do, oops, trying to think the most efficient way to do this. Okay. We're going to do copy list 1. Is this your suggestion, James? Okay. If I do this, I'm going to have the same problem as before, because copy list is a list just like test list 1 is. And so copy list gets sorted. Sorted list is now forever linked to whatever copy list happens to be at the time. And then copy list gets reversed. And then reverse list. And then the reverse list is going to be assigned to whatever copy list is. So sorted list is going to come back as the same as reverse list in this instance. Right? Because doing this just transferred copy list is now our list that we're working with, and we have the same issue. Now, I suppose what you could do is you could do this. And then I suppose this would work. Nope, because Tesla's, yeah, I suppose this could work. Yeah, this would work. All right, but you're still at the mercy of, well, I guess no matter what, you're at the mercy of some list reversing. So this would work, right? You do your sorting, you assign that to there, and then you make a copy and then do the reverse sorting on the copy. Yeah, this could work. But again, this is just to kind of illustrate what's going on. Most of the time, CompuCell is going to handle this kind of detail for you. We just want you to be aware of kind of how the logic of how this program works. One copy for the sort and another copy for the reverse sort. Yeah, you could take a copy of it at a different time. I mean, essentially, that's what I did here, right? I could make 2 copies and then, oh yeah, okay. I understand what you're saying, I think. You can make 2 different copies, copy list 1 and copy list 2, and then sort copy list 1 and then sort copy list and reverse copy list 2. And then those 2 would be the, yeah, that would work as well.